So next property of determinant is, suppose there is a matrix like this where a element is a sum of two elements, means there is an element which is a sum of two elements. So you can separate this element and write two elements, write two determinants and add them like this. So here in first determinant I will write a1, a2, a3, and in other determinant you will write lambda 1, lambda 2 and lambda 3. I have separated these two elements in two different elements. So rest elements will be the same. So b1, b2, b3, b1, b2, b3, it will be same here. So after adding these two determinant, the value which we will get, it will be same. Means there will be no change in value. If you separate this, you can calculate this with Laplace transformation, but if you separate this, the value will be not different than if you do Laplace transformation. So this is the statement here: if some or all elements are written as sum of two elements in a row or column, then you can write two separate determinant by separating the elements and add them. So let's see one example. So this is here, matrix is given. So for cos square theta, I can write 1 by 2 plus 1 by 2 cos 2 theta. For this also sees 1, I can write 1 plus 0. Here I separated 1 by 2 and 1 by 2 cos 2 theta. I wrote here. See here also 1 by 2 wrote here, minus 1 by 2 cos theta I 1 wrote here, 1 I wrote here, 0 here. So you can separate these elements and add them and find the determinant value. It will be same as if you do Laplace transformation. So the next property is interchanging the row or column of a matrix change the sign of determinant. Means if you interchange this row and calculate the determinant without interchanging these rows, the value will be same, only the difference will be in the sign. So here I calculated determinant, I got minus 2. Here I changed the row, I wrote r1 instead of r2. That means I interchange r1 with r2. So I write r1 in the second row and r2 in the first row. So the determinant also I got to, just there was a difference in sign. So changing the rows or columns or interchanging the rows or column doesn't change the value but changes the sign. But if you do elementary transformation, so what is elementary transformation? So I can write R2 as R2 minus 2R1. So R2, which is take one element of R2, 1 into 2R2. See 1 into 2, 2 into 1. So here I can write R2, take one element of R2, 1 minus 2 into R1. So 2 into take one element above it. So R1 element is 1. So 1 minus 2, it is minus 1. So if I do these transformations, the determinant will not change. The value will not change even by doing this transformation. You can do plus minus, you can do this r2 is equal to 2r2 minus 2r1, anything. The determinant will always be same. So in mathematical terms, we can write Ri is Ri plus KRJ. K is the scalar value, I is the row, J is the column number. Also Ci is equal to Ci plus KCJ. And there is one rule here: you cannot do simultaneous operation. You can do simultaneous, but you cannot repeat the row which is under transformation. That means if there is a row R2 and I do one transformation, R2 is equal to R2 minus 2R1. This you can do, but in the same step you cannot take R2 in the next transformation, because here the R2 is getting transformed and you wrote R2 here. So here in this step, are you taking the transformed value or the value before transformation? We don't know. So in this simultaneous operation, you cannot take R2 simultaneously in the next step. So if you do this, the determinant will change. So this is invalid. You cannot do this. See here, this is individual operation. And that means I am not doing it simultaneously. So first I took R1, I wrote R1 plus 2R2. Next R2 plus 2, R2 plus 3R3. This is valid. R3 plus 3R1 plus 2R3. You can do any kind of elementary transformation. The determinant will not change. They are done individually. Similarly in column also these are valid. Here, see here, R1 is R1 plus 3R3. C2 is C2 plus 3C1. R3 you have wrote 3R3 minus 4R1. This is invalid because R3 is under transformation. See in this step, R3 you have written 3R3 minus 4R3. You have multiplied a scalar value to R3 which is under transformation. You cannot multiply a scalar value to the row which you are transforming. So here you can do here 3R2 or 3R1. You cannot do 3R3 since R3 is transforming. So 3R3 for now is invalid. In simultaneous operation, I can write R1 is equal to R1 plus 2R2. R2 is equal to R2 plus 3R3. Here I didn't take R1. Since R1 is transforming, I didn't take R2 here. Sorry, I didn't take R1 here since R1 is under transformation. So this simultaneous operation you can do. You are not repeating a row in another step. But in here I wrote R2 is equal to R2 plus 3R1. Here I wrote R3 is R2 R3 plus 2R2. Here R2 is under transformation. You cannot write R2 in next step. So this operation you cannot do. If you do this, the determinant will come wrong. You cannot do simultaneously row and column operation. You cannot do row first, then simultaneously column operation. In simultaneous operation, you cannot do this. If you do this, the determinant will come wrong. So the ninth property is the ninth property of determinant is if there is a sequence in a matrix. So 1 2 3 4, 1 2 3 4 5 6 7 8 9. So this property for 3 by 3 matrix, if there are numbers in sequence, then the determinant value will be 0. So if there is a sequence, the determinant will be 0. So it can be any order of any order 1 2 3 4 6 7 8 9 10 11 12 13 14 16 2000 2001 anything. So if it is in sequence, the determinant will always be 0.